Hi guys, and welcome back to Maths with Cats. So today's video is about trig formulas and identities. If you just heard a bell, that's my cat. So first we'll go over the trig rules. So the sine rule, the cosine rule, and the rule for areas of triangles. And now my cat's scratching. I've forgotten either. The sine rule. Little a over sine of big A is equal to little b over sine of big B, which is equal to little c over sine of big C. So, this is a side, and this is the angle opposite that side. This is another side, and the angle opposite that side. And this is another side, and the angle opposite that side. It works the same if you put them upside down. The cosine rule. Little a squared equals little b squared plus little c squared minus 2, lots of little b, lots of little c, lots of cos of big A. Now, all the little ones are always sides, all the big ones are always angles, and the same letter are opposite each other. So this is the cosine rule. And then to find the area of any triangle, the area is equal to half of little a, lots of little b, lots of sine of big C. So that, and all of these work for any triangle. Okay, so how do you know which rule to use when? So if you know two angles and a side, the sine rule should be used. If you have all three sides or an angle between two sides, you should use the cosine rule. And if you have two sides and an angle somewhere else, it doesn't work. Here's some examples then. There we go. A ship sails due west for 10 kilometres before turning clockwise through an angle of 145 degrees and sailing in a straight line for another 6.5 kilometres. Find the shortest distance back to its starting point and the angle it would need to turn through to get there. So this is the information we are given to start with. It starts here and it goes 10 kilometres due west. It then turns 145 degrees and travels 6.5 kilometres this way. Okay, we want to find out this length and this, well, no, we want to find this angle because that will be the angle it's turned through to get there, if it's turning the shortest way. So that's the length we need to find. First up though, to make our life easier, we want to find an interior angle. So we're going to do 180 minus 145, which gives us 35. So you can see here, straight line, angles on a straight line add to 180. So 145 plus this must be 180. That's why we do that. So now, as you can see, we've got an angle between two sides. So we're going to use the cosine rule. So a squared equals b squared plus c squared minus 2bc cos a. Okay, so we're going to use this as our A side. We're going to call that the A side. A squared is going to equal to 10 squared plus 6.5 squared minus 2 lots of 10 lots of 6.5 lots of cos 35 is equal to this squared. So a squared is equal to 100 plus 42.25 minus 130 cos 35. So a squared is equal to 142.25 minus 130 cos 35. So a is equal to square root of 142.25 minus 130 cos 35. And that is 5.98 kilometres to three significant figures. So that is the length of this. So now we have all three sides. So we can use the cosine rule again. So this time we are finding the angle. So we're going to call this big A. Now, if we're doing proper notation, we should have changed the letters around, but just to explain it to you, so we're using the same formula, the same letters in the same place, I thought I'd do it this way because it's easier. So here, 10 squared equals 6.5 squared plus 142.25 minus 130 cos 35 minus 2 lots of 6.5 lots of the square root of 142.25 minus 130 cos 35 lots of cos A. So 100, wait, I've just read this line. No. So 100 equals 42.25 plus 142.25 minus 130 cos 35 minus 13 lots of the square root of 142.25 minus 130 cos 35 lots of cos A. So now what we're going to do, we'll move all these numbers over to the left hand side. So we end up with minus 84.5 plus 130 cos 35 is equal to minus 13 lots of the square root of 142.25 minus 130 cos 35 lots of cos A. We can then divide by all this to get cos A by itself. So minus 84.5 plus 130 cos 35 over minus 13 lots of the square root of 142.25 minus 130 cos 35 equals cos A. So cos A is minus 0.283 to three significant figures. So A is inverse cos of that, which is 106 degrees to three significant figures. We need the angle it turns through. So we found this angle, but we want to find this angle to find how far it turns. So we're going to do, I should have done it like that. So we're going to do 180 minus that, because if we just to extend, let me show you. Let me get my pen out. So if we were to extend this line like this, we want to find this angle. We've got this angle from, where is it? Oh, from this. So that is this bit. And we want to find this bit to find the angle it's turned through. So we're going to do 180 minus this bit, which gives us 73.6. So that is this angle, 73.6, and that is our answer for the angle. And we've already got the answer for the distance. Here's another example. In the triangle ABC, A equals 2 pi over 9 radians. Little a is 27 meters. B equals 4 pi over 9 radians. Find the missing angles and the sides and the area of the triangle. So this is the information they've given us. Angle A is 2 pi over 9. Let me change back to my laser pointer. Angle B is equal to 4 pi over 9. Side A is 27 meters. Wants us to find the missing angles, sides, and area of the triangle. So angles in a triangle add up to pi radians. It might be easier for you to think through the process of the angles of a triangle add up to 180 degrees, because you've been doing that since GCSE, and then convert to radians. It's up to you, but they add up to pi. So the angle C is going to be equal to pi minus the two angles we already have, which gives us C as pi over 3 radians. We now have 3 angles in a side, so we're going to use the sine rule, which means that 27 over 2 pi over sine of 2 pi over 9 is equal to B over sine of 4 pi over 9. If you then times up by sine of 4 pi over 9 on both sides, you will get 27 sine 4 pi over 9 over sine 2 pi over 9 is equal to B, which gives us B equals 41.4 meters to 3 significant figures. Okay, we can use sine rule again to find the other side. So we then have 27 over sine of 2 pi over 9 is equal to C over sine of pi over 3, sorry, I lost where I was up to then. Which can, if you then times up by sine of pi over 3 on both sides, you end up with 27 sine of pi over 3 over sine of 2 pi over 9 is equal to C, which is 36.4 meters to 3 significant figures. So we've now found all the angles and all the sides. So we're going to find the area of the triangle next. So the area of the triangle, half AB sine C. So we're going to do half of 27 lots of 41.4 lots of sine pi over 3, which gives us 484 meters squared for the area of the triangle. It is a bit complicated, but it's something that you need to be able to do, and you will get used to doing it because you'll use it quite a lot in geometry. Okay, last slide, trig identities. Tan x is the same as sin x over cos x, or identical to. Sin squared x plus cos squared x is identical to 1. That's it. There are some more identities which we will cover probably in the next video. Let me check. Oh no, it's trig graphs next. But it won't be long before we cover some more trig identities. Yeah, it's not very long off. So the main thing you need to remember, rearrange this. So if you want sine squared x, that's equal to 1 minus cos squared x. If you want cos squared x, that's the same as 1 minus sine squared x. Very useful for when you're solving trig equations. But that's all from me. So if you've got any feedback, can you leave it in the comments below? Like, share, subscribe. I'd be really grateful. And I will see you in the next video. Bye bye!